the first lesson of the year. So through this lesson, we're going to go through and learn how to multiply polynomials. So for the opening exercise, I'm asking you to multiply two numbers without your calculator using something called the area model, which you might remember from middle school. You did something like this in middle school. So how do you use the area model? So you're going to make a section here of boxes. And this is just like a graphic organizer. So I'm going to take the number 28, I'm going to break it down to the numbers 20 and 8, and I'm going to put 20 up top and 8 up top of one of each column. And then I'm going to take the number 27 and break it down to easier parts like 20 and 7. So using our great multiplication skills that we have, 20 times 20 is 400. 20 times 7 is 140. We know that because 2 times 7 is 14. 8 times 20 is 160. And 8 times 7 is 56. Now, these two things are going to add up, so we have 300 in total. So I have 400 plus 300 plus 56. These ones across usually add up to a nice number. That's why I did that. And if we add all of that together, we have 756, which you can totally check right on your calculator. Now, why all this is useful in algebra, because this is not algebra, this is multiplying numbers. You learned that in elementary school, right? Because we can now apply this same skill to an algebra problem. So say instead of having the number 20, I replace it with a number x. So here I said use the tabular method to multiply the numbers x plus 8 and x plus 7 and combine like terms. So if I take that same method, but instead of putting 20 in, I put x where the 20s were, and I keep the 7 and the 8 in the same spot, x times x is x squared, x times 7 is 7x, 8 times x is 8x. Remember, when you multiply variables, right, we add the exponents. That's why x times x is x squared. And when we multiply a number and a variable, they just kind of go together. These are going to add up to become 15x's. That's a 15. Let's fix that. That looks like an 8. So that's a 15x. 8 times 7 is 56. And if we put all this together, we get x squared plus 15x plus 56. This is actually the same answer above. If you were to square 20, you would get 400. If you were to multiply 15 times 20, you would get 300. So this looks very different. It's actually the same problem, or the same type of problem. So we're using this same process. Then it says, how can we multiply these without a table? This would be a question I would ask all of you. And I'm going to say, what's the property that you would use to multiply these out? I'll even give you a hint. You might have remembered doing this in Algebra 1. And your teacher probably drew arrows. Does anybody remember what that property is? Good. If you put down the distributive property, you did that question right. So this is the distributive property. Meaning there are two methods to be able to answer all of these questions. So let's keep going here. So it says use the tabular method to multiply and combine some like terms here. So notice I have a 3-term polynomial times a 3-term polynomial. So I'm going to need to make a lot more boxes here. I need to make enough so it's a 3 by 3. I'm going to have 9 boxes. So I have x squared, I have 3x, and I have 1, x squared, negative 5x, and I have 2. So in this first box here, we're going to wind up having x squared times x squared, which is going to become x to the 4th power. Remember, when you multiply variables, you're adding their exponents. X squared times negative 5x is negative 5x cubed. Again, we're adding 2 and 1. There's an imaginary 1 here. And then we wind up having 2x squared for that last box. Now, if we keep going here, we can fill out the rest of this table. So this is a good opportunity for you to pause the video and try the rest of this table yourself. I'm going to keep going, and then you can see if you got the same answer as me. All right, so if you got those 6 boxes filled in correctly, you're in really good shape here. So now let's start to look at what we can combine. Things that are across from each other can combine, right? So these all have the same variable, same exponent. So my x cubed terms, I have a -5 and a +3. That's going to give me a -2x cubed. My x squared terms, I have a 2, a 1, and a -15. That's going to give me a -12x squared. I'm just adding these coefficients up, right? 2, -15, and 1 combined together to make -12. 6 and -5 combined to just give me 1, so we'll just put x there. And then we can write our final answer. So our final answer in the right form is x to the 4th power minus 2x to the 3rd power minus 12x to the 2nd power plus x plus 2. This is our polynomial. Now there's a couple things we could talk about regarding this polynomial. One of them is its name. Because of the term of x to the 4th, this is what we call a quartic polynomial. Just like we have quadratics, meaning the exponent's x squared, or we have cubics, meaning the exponent's x cubed. If it's an exponent of 4, it's quartic. Just a fancy name for that. All right, so let's keep going here. So if we go on to my next example, it's more of the same. Right, using the tabular method, we can multiply this out. So let's multiply this out. So we wind up having a bunch of boxes here again. But we're going to notice something different happens if we set up our boxes. So when I set up my boxes, because that second polynomial is missing the middle term, when I multiply this out, and again, I'm hoping that you're doing this with me, you're just not watching the video, right? We wind up having terms that aren't like terms across from each other like in the last problem. Not a big deal, but something that we'll have to consider in an upcoming lesson. Okay, for right now, we just multiply it out, look for like terms. So for this, it might be a little bit easier to circle like terms. So here's a like term, and here's a like term. There's nothing else that's common, so we can write our final answer. So we'd have x to the 4th power. We'd have a plus 3x cubed. Notice I'm trying to go in order of the exponents. The exponent should always decrease, right, or ascend, however you want to say it. And we wind up getting our answer here, another quartic polynomial. All right, let's move on. So number 4 says use the distributive property. So we've been using this tabular method. Let's do some distributing. So one of the things is, and especially for this class, there might be a method that you like better. If you're a distributor, totally use distributing. If you like the box method, use the box method. It's up to you. What are you going to like better? So here's how the distributing method would work. I'll do one example like this. I'm going to multiply this first term of x times everything in this second polynomial. So x times x squared is x cubed. X times x is x squared. X times 1 is x. Then I'm going to take the second part of that first polynomial, and I'm going to distribute that to everything. So what I'm getting here that's going to come out in green is my multiplication of -1 times x squared, -1 times x, and -1 times 1. And then we have to look for like terms. We have a like term. We have a like term. So we want to combine up our like terms that we have here. I like to underline them. If you're a circle and box person, that's fine too. So I have x cubed. My x squared terms cancel. My x terms cancel, right? A positive x squared and a negative x squared would cross off. A positive x and a negative x would cross off. And I'd be left with -1. X cubed makes this a cubic polynomial, right? Knowing the names is important because they might come up in a question. They might say a cubic polynomial looks like this, and you want to know what they're talking about. Okay, so quartic means x to the 4th power is the biggest exponent. Cubic means x to the 3rd power is the biggest exponent. Number 5 is more of the same. We're going to skip number 5 and number 6. They're not necessary for us to go through here. We're going to just skip over them. And number 7 is kind of a challenging question. So let's all take a look at number 7. right? So number 7 is us going through and multiplying this crazy polynomial that has no numbers in it, and it says squared. Whenever I see something squared, we have to remember that means multiply it by itself. So I have x, a plus b plus c times a plus b plus c. So I like this problem for a lot of reasons. So if we were in class, I'd actually say turn to your partner and try this problem with them. I don't want to do that now. Obviously, we're home. I can't do that even if we were in class. But it's important to see that there are some algebra issues that come up here. A times a is a squared. A times b, how do we write that? Do we just write that as ab? Do we write that as ba? Always try and go alphabetical when you can. It makes combining of like terms easier. Same thing when I multiply a times c, I'm going to write that as ac. B times a, we don't want to write ba because that would look different from ab. So I want to write ab, right? Multiplication is commutative, so I can write it either way. B times b is b squared. B times c we'll just write as bc. C times a, again, alphabetical here. AC looks better. B times c, bc. C times c, c squared. So if we start to write this final answer, which is going to look kind of crazy, I'm going to write a squared plus b squared plus c squared. I'm going to get rid of all those things that are squared. They're not going to have any like terms. And then I'm going to look for like terms. I have a like term here. I have a like term here. And hey, look at that, I'll even use the fancy pen. I have a like term here. Right, so things circled in blue, how many of them are there? There are 2 of them. So I'm going to say plus 2 ABs. Plus, things circled in green, there's 2 of them, 2 ACs. Plus, things circled in crazy color, 2 BCs. There's my answer. We don't need to name this one. It's just a crazy looking polynomial. That's about as hard as it gets. If you can do that, you can do any question I could ask you about multiplying polynomials. Hopefully this lesson got you through and you understood some stuff. If you need to, you could go back and rewatch parts of it. Make sure that you're doing your online assignment that attaches to this, and I will see you all when I see you.